Hello, ladies and gentlemen. Mr. Johnny here, looking at 9.1 and 9.2 problems. It has to do with molecular shapes and the valence shell electron pair repulsion model. All right, so number one, for a molecule with the formula AB2, the molecular shape can be what? Well, let's think about it, all right? If it's AB2, well, if it had no unshared electrons, it's simply going to be linear, right? B's are going to spread out as far as they can away from each other. You're going to get a straight line. You could have also had one lone pair on that A, which would take up space, and you get a slightly different shape, which would be bent, right? And same thing, if we put another lone pair of electrons on there, we're still going to have a bent shape, but it's just going to be a little more bent, right? So it's either going to be linear or bent, right? You can't have trigonal planar if you only have two things attached onto that A. Same thing with T-shape. You need three substituted things instead of just two. So, yep, choice A. Number two, for a molecule with the formula AB3, the molecular shape is what? Well, it can either look like this. There can be no unshared electrons on that central atom, and it would look like it was trigonal planar. All right, so that's trigonal planar. It could have also had, well, hey, what would happen if we had a lone pair of electrons on that central atom? Right, this kind of looks like NH3, which would be trigonal pyramidal. All right, so we want trigonal planar, trigonal pyramidal, and the other possible shape is if it had two lone pairs on that central atom. What would that look like? It would be T-shaped, right? This one looks T-shaped. That looks T-shaped when written in 2D, but it's not. It's actually trigonal pyramidal. And this one is actually T-shaped. So the correct answer for 2 would be E. 3. ClF3 is T-shaped geometry. There are blank non-bonding domains in this molecule. All right, well, easiest thing to do would be to draw the Lewis structure. So we put Cl in the middle, F, 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 complete the octets. And now I've used 24 electrons, but let's see, I should have 28 valence electrons. So I need to put the other ones on that central atom. So I have two non-bonding domains, right? The two lone pairs of electrons. Right? You might also start to realize that T-shaped things have to have two non-bonding domains. 4, the electron domain and molecular geometry of BrO2. Well, let's figure out how many valence electrons we got. We got 7 plus 6 times 2 plus 1 because of that negative sign. So we get a total of 20 valence electrons. So we put the less electronegative thing in the middle. We put Br in the middle. Oxygen. Oxygen, I don't know where it's really going to go yet. I might have to change my shape. Complete the octets. I've used 16 of 20. So now I got to put two unshared electron pairs around bromine. Well, I know that's going to be bent molecular. Like if I'm looking at, this is the same kind of structure as H2O, right? Two bonding domains, two non-bonding domains. Well, that means our electron domain geometry is going to be tetrahedral, right? And our molecular geometry is going to be bent. So we're looking for a tetrahedral and bent. Choice D. 5, the electron domain geometry of blank is tetrahedral. So they want us to check all of these things. So I get, all right, well, let me figure out how many electrons there are. 4 plus 7 times 4. So I get a total of 32. I get 3 times 1 plus 5 equals 8. I get 4 plus, I'm skipping steps, plus 14 plus 14. It gives me 32. And then here I got 28 and 8, which gives me 36 valence electrons. So I'm going to cheat, and I'm going to show you just the one that doesn't work out to be tetrahedral, right? So pH3 is going to be like NH3. It's going to make bonds to 3 different hydrogens, and it's going to have one unshared pair of electrons that it keeps to itself. That makes the electron domain geometry tetrahedral because there's 4 domains. All right, but if you take a look at XeF4, it will not. All right, so I put it all over there, place my valence electrons around it. I've used up 32 of my electrons, and I still have 2 more to put, 2 more pairs to put. So that's definitely not a tetrahedral domain. So here, choice E. 6. Of the following species, blank will have bond angles of 120 degrees. So we're looking for 120 degrees. Well, I know that trigonal planar would have 120 degrees, right? So let me see what's going on. pH3 I just did on the one before. It's going to be trigonal pyramidal. ClF3, well, that gives me a total of 28 valence electrons. So let's see what that would look like. I put Cl, 3 fluorines. Complete the octets. I've used up 24 electrons. I got to put 4 more. So 2 lone pairs around that chlorine. This is going to be trigonal bipyramidal. So this will have 120 degrees between the domains, like if we were to look between on the equatorial plane between the lone pairs of electrons and the fluorines that are also on there. But that's not the bond angle. We're talking about this. That's going to give us a bond angle of 90 degrees between the atoms. All right, so it's definitely not B. All right, NCl3, well, it's 5 plus 21. I got 26 valence electrons to place. So Cl, 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 complete the octet. I now have 24 electrons placed, lone pair there. This is going to be tetrahedral, which is going to be 109.5 degrees, and that's not 120, so it ain't going to be that. BCl3. All right, well, boron gives me 3 plus 21. I get 24 valence electrons to place. B, Cl, Cl, Cl. Complete the octets for the chlorines, and I will have used up all of my valence electrons. No lone pairs. This would be trigonal planar. It's going to have a bond angle of 120 degrees. Bingo. 7. The bonds marked A, B, and C in the molecule below are about blank, blank, and blank respectively. All right, well, let's take a look at A. If I'm looking at this nitrogen, I got 1, 2, 3, 4 domains. So 4 domains is going to give me a tetrahedral electron geometry, which is 109.5 degrees. If I take a look at this B, I have 1, 2, 3 bonding domains. So if I have 3 domains, it's going to be trigonal pyramidal, which is going to be 120 degrees. And then I'm going to take a look at C, where there's 1, 2, 3, 4 bonding domains again. So it's going to be tetrahedral with bond angles of 109.5 degrees. So which answer would that be? It'd be choice B, as in David. All right, I hope you found that helpful. See you in class, bring some questions, and all that good stuff.